Okay, Assalamualaikum. Welcome back. We continue our lecture for today. The next one will look at the method. The next method we want to consider for solving particle kinetic problem. Okay, by integrating the equation of motion with respect to time. Okay, so the result is referred to principle of impulse and momentum. Okay, so it can be applied to problem involving in both linear and angular motion. You can use this equation for linear motion and also for angular motion. Okay, so if you want to apply this um, if you want to apply this technique, it have to involve with this one, force. You must have the velocity and okay, so have force, have the velocity, and time. Okay, if we have these three things, you can use this principle. Okay, so it can also be used to analyze mechanic of impact. Okay, topic of impact. Okay, but for this session, I don't think we will cover the impact. We are going to come up to the impact. So we continue. The next session is we talk about the principle of linear moment, principle of linear impulse and momentum. Okay, so this is to give you the fundamental. Okay, fundamental of it. Okay, let's say for example a particle. Okay, having an acceleration of a. Okay, the acceleration of a under the action of force p. So we have here acceleration particle, and then this particle having acceleration a, and then under action force, okay, action force F. Okay, so the equation that we have, this is again F equal to ma. Okay, equal to ma, which is a Newton's second law. F equal to ma. Okay, so we can write F equal to ma. Okay, equation equal to F equal to and acceleration. So A, we know that we have learned before, acceleration is dv dt. Okay. We differentiate the velocity with respect. So we can cross multiply both sides. Okay. So you get f dt. Okay. F dt equal to mdv. Okay. So we substitute here. It's going to be f equal to m dv dt, and then you cross multiply both sides. You can get f dt, okay, equal to m times dv. Okay, all right. So if we let v1 be the velocity, okay, we know that of course v1 is the velocity, but v1 is the velocity at time 1. Okay, if at time 3 v3, v2 is v2, right? So we follow that order. So v1 is the velocity at t1, and v2 is the velocity at t2. So the above equation, this equation, and the above equation means this equation, we can integrate. Okay, this equation, okay, the one that we have obtained just now, we can integrate. Okay, integrate both. We integrate here. Okay, we integrate both, and it becomes, okay, as the following. So you can get f dt You integrate V1, V2, so you're going to get M times V2 minus V1. All right. So the summation, okay, of this one, okay, summation of this one represent the linear impulse. Okay, this one. This is summation of f dt integration from T1 to T2. It represents linear impulse on the particle. Okay, this is your equation on your left hand side. And then for this one, this is mv. This is linear momentum. Okay, and this one is linear impulse. Okay, all right. So we take this one as equation 2.1. Okay, 2.1. Okay, so this equation, okay, this equation 2.1, okay, this equation, this one, this equation is known as the principle of linear impulse and momentum. So the name of it is principle of linear impulse and momentum. Okay, where we express linear impulse on force F, okay, on the body during the time interval from T1 to T2. Okay, is equal to the change of linear momentum. Basically, this word, basically it explains this equation. Apa yang dia cakap sini? Linear momentum of the body of the force on the body during time interval equal to the change in linear momentum. MV is linear momentum. Okay, that's the meaning. When you put it in paragraph, so this equation, the when we put in writing is it say like this. Okay, so next one we proceed to explain the concept. Okay, when there is more than one force, just now we take only single force. This time what will happen when we have more? Okay, more. Okay, more than one force acting on the body. Okay, acting on the body. So the what's the name of the principle just now? Still remember what is the name? What is the name? Principle of impulse and momentum. Okay. So if we have more than one force acting on the body, so we put this summation sign, right? Summation, kan? We put summation. Summation. Okay. Summation of force equal to, again, M times V1 minus V2. So what is V1 minus V2? This is delta V. Okay. So you have summation here, and then you have delta V. All right. Then we want to define this one. Summation of force represent the sum of impulse by all forces acting on the particle during the time interval from T1 to T2. Okay, so we are going to put this way. We say L equal to mv. Okay, and then it is the linear momentum of the particle, and then impulse, we can say this way, integral from 1 to 2 f dt, which is the impulse of force during the time period T1 to T2 with the unit of ns. Okay, so therefore, okay, by having this statement, this equation 2.2, we can write as the following. So we have summation, okay, from T1 to T2, we have force dt. This time we want to write in terms of L equal to L2 minus L1, which is, this is delta L. Okay, that's how we present. We can represent in terms of L as well. Okay, so I name this one as equation 2.3. Okay, to make this concept clearer, we look at this figure. Okay, this figure. Okay, this figure basically is the figure of linear impulse and momentum of the particle. Okay, we have this figure. We have initial momentum and final. Okay, you see at T1, this is initial momentum, and then this is at T2. We have initial, we have final, and then we have during between time T1 to T2, we have impulse. Okay, so we have here initial momentum, and then we have final momentum, and then here we have impulse. Okay, so I have defined all of that just now, right? So we have here L1, we have here L2, okay, and here we have impulse. Okay, so by this drawing, I think it can make it clearer to us. Okay, so L1, okay, at T1, this is initial momentum. You have mv1. Okay, so for L2, you have mv2. Okay, and then during the impulse, we have the summation of integral f dt, and then you have the time, okay, during T1 to T2. Okay, all right, this is about the figure. Next one, the equation that I have mentioned just now, equation 2.2, 2.3, we can express those equations. We can express also in in the component of x, y, and z. Okay, in its scalar component. Okay, so for scalar component, we can write in this form. Okay, similar. Just just to make it clearer, I just write it. Okay, we have t1, t2, and then this is the summation of fx dt. Okay, so we want, this time we take x component. This is for x component. So we write L x2 minus L x1 equal to m Vx2 minus Vx1. Okay, so basically what is this? This is delta Vx. Not big V, but small v. Okay, small v. If big V is a volume, small v is a velocity. It's a velocity. This is volume. Okay, so we don't use this one. Okay, same thing for y. This is x. This is for y, and this is for z. Okay, so we can express this equation. Okay, this equation in its scalar component. Okay. Another way to express linear and impulse momentum, we can use we can use in terms of linear impulse momentum equation. Okay, so we can also express this equation by using the following. Okay, all right. So it's going to be, we can write in this form. Okay, which may define as the final linear momentum of the particles, okay, equal to its initial momentum plus linear impulse, okay, over a finite period of time. Okay, so you can write, we have here equation 2.5. So we have L1 plus summation of, okay, impulse 1 to 2, okay, equal to L2. Okay, okay. And then this equation from above, we apply this, we have a dvdt, and then from here dvdt, we know that mv is L, so it's going to be dl dt. Okay, this mv is L, right? So we have dl dt. So when still remember last time, if x we differentiate with time, it's going to be x dot, right? If y we differentiate with time, then to be y dot. So if L we differentiate with time, it's going to be L dot. So we have L dot here. Okay, the LDT equal to L dot. So therefore, F equal to L dot. Okay. All right. We proceed to do example. Okay. To make it clearer, we do this example. Okay. Okay. Do this example. I'll give you 1 minute to read this question. Okay, we continue. I think this problem is the same from the example that I have mentioned just now. But the only thing here, you have to find, we have to use the theory that we just learned just now. Okay, same problem. Okay, um, so we have to use the answer that you have obtained earlier. Okay, okay, because this is just like a building block. So we have again same mass, horizontal plane. Okay, initially moving at 10 meter per second. Okay, under action of two forces, duration, okay, 5 seconds. So what you need to do here is you need to find the final velocity of the sphere at the end of 5 seconds. Okay, so assumption here, no friction. Okay, no friction. You see the datum here, check the unit, okay? Check the unit, because this one we use the earlier result. So this time we use the theory that we just learned, which is impulse momentum equation, which is this equation, okay? So this equation we have obtained just now, V1 plus summation of impulse 1 to 2 equal to MV2, okay? All right. So how we going to do this? First thing, I think we need to do the diagram, right? Can you draw the diagram? Okay, diagram. Okay, initial, final. Okay, in between, impulse. Remember this one? This one? Initial momentum plus impulse and then final momentum. Okay, so you need to draw like this way. This is the first step. Okay, can try. We have here, we draw first plus second one equal to, okay, this is initial, final, and this is the impulse, right? Okay, initial is this one. This is initial. Okay, initial. Copy exactly this one. Okay, the velocity. We have here mv1. Okay, angle, same angle, 40. Okay, next one, impulse. This one, right? So you put, this is the impulse. Another one going down. Okay, so you write the equation, the integral. Okay, you write the integral. Okay, 0 to 5. Then you have f dt. And then next one, same thing, 0 to 5 seconds. And then this is f2, right? F2 dt. Okay. And the third one is the one, the final one. Okay. So for the final one, I take this one as a datum. Okay. As the datum. We do not know, the direction of it, and also we do not know the value of it. Okay. Okay. So you need to apply this equation. This is the equation that you need to apply. So this is the diagram that you need to draw to answer this problem. Okay. So from the previous equation that you have, previous example that you have done, okay, we already know the value of L. Okay, L1 we know already. Okay, impulse also we have calculated also. Okay, L1 we know already. Okay, and also impulse also you have obtained in our earlier example. Okay, 1 to 2. Okay, so L1, where do you get L1? This is from previous example. Previous example, we have L1. Okay, L1, which is minus 5.75, okay, plus 4.82. This is L1, okay. And then impulse from 1 to 2, we have calculate impulse also just now. impulse. You get 32.5. Remember, I asked you to calculate 34.5. This is the impulse. Right? You have calculated impulse. In example 15.3 kan? 32.5 minus 42.5. So these two. I obtained these two values from our previous example. Okay. So we have here. Okay. So L1 we took from previous example. So you get minus 5.75. Okay. Right. Plus 4.82 J. Okay. Meter per second. And for impulse, you get 32.5. Okay. I minus 42.5 J Newton per second. This one from previous example that we have done, earlier example. All right. So based on that, we want to put together X component and Y component. Okay. Now we put X component. We take X component positive to the right. So you get minus 5.75 plus 32.5, okay, equal to 0.75. Based on this formula, 0.75 Vx2. Okay. So please tell me what is the value for Vx based on this equation. So Vx2 will be, what is the value? Can you calculate for me? Same thing for y here, plus y, okay, y component going up, okay, it's positive. So we take 4.82 minus 42.5, okay, equal to 0.75 Vy2. Okay, we can solve also for Vy2. Okay, what do you get? You can write in our chat room. No problem, let me check what is your answer. You can type there Vx2 and Vy2. Okay, please. Okay, Vx2 35.7. Okay, let me check the question.
Apa dia? Sudah habis. Iya, tu tidak jadi.
35.67. How about Vx2? 35.67. 35.7 lah. So 35.7. The unit is meter per second. And then Vy2 is minus 50.2. Okay, minus 50.2. Okay. Okay, we didn't finish yet. The question asks us to read the question carefully. The question asks us to find what will be the final velocity. Okay, final velocity of the sphere. Okay, so final velocity. So we have to add up these two together. So V2 equal to 35.7 I, okay, minus 50.2 J meter per second. Okay, all right. We have done for the talking about this example. Okay, any question about this example? I think if not clear, just let me know. So I can elaborate further. This is a concept of impulsive motion. Okay. Okay, we stop here. Take a break for 5 minutes. Okay. And then we're going to continue to discuss about other concepts.